So yesterday we discussed about this Spark streaming part, right? That in Spark streaming we can go with the checkpointing so that it can have all the references for the previous processing and what it has to do next. And streaming part we can handle either with the Spark or with Kafka or maybe with various sources. Using a Spark, you can have various sources that can be Kafka also, that can be something else also. Let's say you are having some file source or maybe some other direct API source, or like you can have sockets and all that also you can do. So here, if I am coming here, you can see for the Spark streaming, that's a real-time data processing engine running with the Spark. And the main thing for this is continuous data processing. As soon as data is keep on generating, that should be processed either in continuous data stream or micro batches. Micro batches in the sense that's not historical also, that's not actual real time also, but that is having some intervals. That's the micro batch. And this supports data sources like Kafka, Flume, HDFS. HDFS means a storage part. So that storage can be anything. In Hadoop, it is HDFS. In cloud, it can be different according to the cloud, right? So that can be different. Then we have some window functions in Spark. So that windowing allow processing of data within a specific time range. Like what is the time range you want to process, and it helps analyze time-based event efficiently. Like, let's say you are processing real-time data only, but you want to check how many customer logged into the website in last 10 minutes. That means your data is keep on processing continuously, but still you want to compare and you want to do aggregation, all the things with current data to last 10 minutes or 5 minutes, whatever data you want. So that time is specific time based upon the time events, there can be some analysis. So that is going to help you with the window. And this is commonly used for aggregation, trending analysis, and pattern detection. Trending analysis, okay. So let's say you are looking for to trend. Okay, suppose uh, you are working for a e-commerce website and there some thousand products are registered, which is for the sale. Now you want to check out of in last 10 minutes which products are having more order, or from which location order is coming more, or what kind of products are getting reviewed in this last 30 minutes or 1 hour, or yesterday, or yesterday will be too far, it's completely history kind of data, but you can take for a few minutes to 1 hour 2 hour kind of that, and that is going to help you for doing the trending analysis, pattern detections and all. Then you have tumbling windows. There are the type of windows. Like just you can simply assume at a high level that whenever your data is coming from the source and continuously you want to process, then that's a simple streaming. You wanted to process with the time, with the micro batches, then that's micro batch. Why you are looking for time to process? Because maybe your data is coming too much, resources are not supporting according to the data, or data is something like maybe sometime it is coming with a few thousand only. In the next it can have some lakhs of records that can be there. Then how your application is going to be handled this much up and down? Or maybe sometimes it is pushing the data, means you, if whenever you are trying to read, it is your Spark is pulling the data sometimes 1,000, sometimes 2,000. So when it is pulling 1,000, then it is running fine. Whenever it is getting 2,000 or more than that, then maybe this that is getting stuck, block, or processing time is going to be low, or this is kind of hanging situation. So in that case, you can manage that with macro batches, that okay, how many data is coming from the source doesn't matter. Let's keep on processing thousand records for each of the second, like that. So there will not be any overburden for each of the second. that will be pulling this much record, this will be processing, and then it will be keep on doing the same thing in the repetition mode like that. So in that condition, we go for the micro batches. As I said yesterday, we have both the option. Either we can set the number or we can go with the size as well. That okay, in the last 2 minutes, if data is like um, meeting with this number limit, then process that. Or you can set up if data is kind of 10 MB or 20 MB or 100 MB, whatever you are looking for, then process that windows. You can have the setup. Then you have tumbling windows. So tumbling windows means fixed size, non-overlapping and non-overlapping time intervals, and each window process event occurring within that time frame only. Okay. And then you have example wise counting every events to every 10 seconds. So let's say you want to count that every 10 seconds what is happening, and what if you are thinking about okay, this product is it's set to go on the sale, and that is as most of the orders are coming, then what is happening for that last 10 seconds, or how many let's say you are having a website and you are just looking for how many visitors are there for this website in this last 10 minute or in this last 20-minute kind of that. So you can do kind of counting and all. Means this kind of aggregation you can do. Here you have window data frame. If you want to go with this syntax, then simply you can say this is window, then timestamp, and here you have to define this timestamp 10 seconds, but there will be no overlapping. I believe that you understand about the overlapping, where it will not care about the previous time. Okay. And then you have next one. This is sliding window. So window is having some types. One is sliding, one is tumbling, where you do not have overlapping. Whatever timing you are defining with that time only, that is going to process. And then you have sliding window. So in sliding window, it is having fixed size window that slides that data whatever you are looking for at a defined interval, and it is having overlapping time windows allow event processing multiple times. Okay, like count events every 10 seconds with a slide interval of 5 seconds. That means you want to count with 5 seconds, but you want to take the data of last 10 seconds. That means it will be taking current 5-second data and the previously 5-second data. Then only it can do for 10 seconds, right? Or it will be having something different. What do you think here? No idea. Okay. So the thing is, when data is coming from the source, either you are looking for any kind of aggregation at the same time only, or you are looking for some overlapping also. So if you are looking for the overlapping, then you may go for slide window. Here, if you see timestamp 10 seconds and 5 seconds. And here you are saying that count events every 10 seconds. So this is streaming. Okay. Data is keep on coming to your system. You are keep on consuming, you are keep on processing, everything is going on. But in the same time, you want to open this grouping, this aggregation as well. And for this aggregation, if you are opening this window, this will be having that state for the data. It will be taking the count for each 10 second, and you are saying 5 seconds. So for each 5-second interval, this will be giving you trend of 10 seconds. That means for 5 seconds, this is capturing 10 seconds data. That means it is having 5 seconds overlapping. Okay, then you are having session windows. So session windows is dynamic sized, window based and user activity. And a session window closes when there is inactive beyond a threshold. So let's say you are saying that whenever data is coming, do the aggregation. But there can be a condition when there is no data or there is no active user, then you can have a setup. And with that setup, your system will be working, or it will be kind of have a stop. Okay. So tracking user sessions with a timeout of 30 minutes. Let's say you are defining a timeout. In that case, window df, you here you can do that session window you have to provide, and you can say timestamp 30 minutes, and then you can take the count. So accordingly, this session window will be working out. Then you are having one more global windows as well. So this is going to process the entire data set without a fixed time boundary. You do not have anything. This is, you can say, normal. You do not have any overlapping, any timing details and all. And this is useful for computing aggregation over a full data set, because you are not having any kind of time overlapping and all. Where, for example, computing total sales over the entire stream, like data frame dot aggregation, and then you are doing the sum. Finally, if you want to do some use cases for the windowing, then you can using fraud detection in the real-time transaction, because fraud detection, what happens? You are going to work with some overlapping, right? You need some last 2 seconds or last 5 seconds, that in last 2 seconds, what is the user activity, or how many are having a failure with their login, or how many are having some notification or some review. So that kind of detection can be done with some time window timing. Then log analysis and monitoring, real time user engagement tracking, that if you want to track the users engagement with your website or with your product or with your whatever you are having. If you have any product and you are just looking out what is happening, or how many are there, or how many orders are happening, or maybe some other activity that can be. Then IoT sensor data processing. If you are doing this kind of work, then also this window function is going to help you. And again, if I talk about the interview, then most of the questions will be around your either you suppose question can be, if you have worked with the Spark streaming, then what kind of work you have done. That can be the major question. When I am coming to windowing is having some completely different concept, where this is working with processing. Along with that, this is taking care for some window session. Means it is just opening a window, and this is working with the time range. Okay. And for interview, I can say very less question around this. If honestly I speak, then if I talk about my experience, then as of now, I have got, I guess, one or two time max this type of question. Otherwise, all the questions run around normal streaming only. Okay, but better if you can have understanding. But Windows you should understand. Okay, so main thing is when data is if we are talking about the Windows, then when data is coming to the input stream, and then we are going to process that. Fine. And this is for the event time and late data. Event time in the sense, let's say data is coming to the event. As soon as data is coming, we are going to process. And late data, if data is late because of some reason, then how you are planning to process that? Let's say you are having the data to process. Okay, you right now 7:30, so 7:30 minute. Maybe 7:30 data got stuck somewhere like, with the network, or maybe some other region, and that data is arriving to 7:40 or 8 a.m. Then how you are going to handle that? So these kind of things you can handle. So event time is the time embedded in the data itself, and for many of the application, when we may want to operate on this event time, then we may get event numbers generated by the, let's say if I'm taking the example of IoT device only, then the events generated by IoT devices every minute, then we probably want to use the time when the data was generated, and what is the event time in the data. And we are not focusing on when Spark is receiving the data, because for all the data purpose is different. Whenever Spark is receiving the data, that is fine, but when data was getting generated, that is fine. And then you have if we talk about major things about this windowing, then you can mostly focus on this three part only. how you can do this window operations on event. If any window operations and events are coming, then this tumbling window, sliding window, and session window. We discussed this, right? Tumbling, sliding, and window, and then you can have the differentiation between that. So if I talk about this, uh, all of this, then you have simply what you are going to do. You are just going to handle the data with some aggregation, with some time overlapping. That process the current data also, but it takes some time overlapping with the next data or previous data will maybe 5 seconds or 10 seconds like that. And another thing is handling late data and watermarking. So you can just consider that if one of the event arrives late to the application, uh, okay, for example, let's say that word is getting generated at 7:30 a.m. Right now it is kind of 7:35. So word is getting generated with that. So that is the event time, actual event time, and it could be received by the application by 8 a.m. That means there are some few minutes delay, right? So the application should use the time 7:35 only instead of 8 a.m. to update the order counts for the window. Okay, so what I want to say, let's say we are saying that get total order of the last 10 seconds or last half an hour, 30 minutes. Okay, so you are what you are trying to get just count of orders, how many orders were placed in last 30 minutes. One order was placed to 7:30 only, but we received in our system by 8:10 with some late. Now, when you are trying to count how many orders were placed within this 30 minutes, then you are trying to count 7:30 to 8 a.m. That is the 30-minute window. In 30-minute window, you did not receive the one of the order, and that order is you. That order you are receiving at 8:10. That means 10 minutes late. But where that data should get counted? That data should get counted with 8 a.m. to 8:30 or 7:30 to 8. In which window that should be counted? What do you think about this? I hope you are getting the point. So my point is, let's say we are saying that this is 7:30 to 8 a.m. 8 a.m. We are just opening the window and we are trying to get count of the product. Count of the ordered product. And one order which was placed by 37:35, but you are receiving it at 8 8:10 a.m. This product count should be in 7:30 to 8 or it should be 8 to 8:30. What it should be? What do you think here? Any comment from anyone?
7:30 to 8.
No? Okay. So this product was ordered within this range only 7:30 to 8, right? Even this is coming late, we are receiving it 8:10 am, that is okay, but it should be counted in this range itself. This is late coming data was generated on the time, but it is getting received late, but it should not be treated in our aggregation with the time when we are consuming it, when we are getting it from the source, but it should be treated with its original time. It's at what time that was generated, that was done. Okay, so accordingly you are going to done, and that we say handling late data. Okay, so if this kind of data is coming, then what you are going to do, the application should use the time actual time, like it was generated at 7:35, then it should use just 7:35 only instead of receiving time. This is the receiving time, this is the generated time. So application should use the generated time instead of the time when we are receiving, to update the older counts of for the window. So when whatever count we are doing for this window, this count should also, this one count should also go to that window itself. And this occurs naturally in our window based grouping, which we say structured streaming, that can maintain the intermediate state for partial aggregation for a long period of time, and such that late data can update aggregation of the old windows correctly. Okay. And then watermarking. So watermarking is something you can say, let me give an example. So suppose you are running the query for the day, and this is necessary to system to bound the amount of intermediate in-memory state. Okay, and that means the system needs to know when an old aggregate can be dropped from the in-memory state, because the application is not going to receive late data. And watermarking, which lets the engine automatically track the current event in the data and attempt to clean the old state accordingly. Like whenever new states are coming for the data, then clean the old states. And accordingly, it will be defining the watermark of a query by specifying the event time column and the threshold on how late data is expected to be coming, and how you are going to do the aggregation on top of that, and how it is uh, keep on handling. So for that, simply you can say, let's say you want to create a watermark, and the example where you want to do some grouping. Okay, so group the data by window, and let's say we are having a simple word count example. So let's do this only, windowed word count. This is simply about handling the data with some overlapping of the time. Word count equal to words, then dot with watermark. You have one option with watermark, and then you are going to give some timestamp. Timestamp, and then let's say we are talking about 10 minutes. So we are going to do aggregation with 10 minutes, and then uh, come to next one. So let's say do group by, and then in group by you have to do window. So window, and then your words. Here we have given words, right? So let's take words dot timestamp, and then you are taking 10 minutes, not seconds, 10 minutes, and then 5 minutes. You just want the overlapping of 5 minutes. And then word, words dot word. That is there. And then let's say you may syntax may be wrong. I'm just trying to give an overview. So here what you are trying to do, this is just a simple word count example. Okay. So in this example, if we look, we are defining the watermark of the query and the value for the column timestamp. This is the timestamp column. Okay. And this is also defining 10 minutes of the threshold. This is the 10 minutes of the threshold, that how late is the data allowed to be. If data is late around 10 minutes, then it is allowed, and it will be get calculated with the current aggregation. So you can define the time for the handling late data. And if this query is running in the and in update output, whatever we are getting the updated output, the engine will keep updating counts of a window in a result table until the window is older than the watermark. Okay, so this will be completely taken care for the time. And it is it is kind of lags behind the current event time in column timestamp by the 10 minutes. That means it is always having the 10 minutes lags, because this is just waiting. Okay, I am allowed to wait for 10 minutes. I am going to handle 10 minutes late data. Then of course this is going to be wait, and this will be keeping the lags. So this is always going to do that. And in this, maximum event time tracked by the engine will be kind of max event time minus 10 minutes. So always it will be going to the last 10 minutes, and then at the beginning of the every trigger, this will be taking the data from the previous time, and then it will be good to handle the last data. Now if we talk about this tumbling window, sliding window, and session window, single line, I will just explain. So if you talk about the tumbling window, let's say for example I will be giving here 5 minutes, and I will be giving here sliding window. And I will say 10 minutes. Just I'm giving example. 10 minutes and 5 minutes. Slide of 5 minutes. And then third one is session window. Session window, let's say cap duration 5 minutes. Gap duration 5 minutes. So here you can see here is no time overlapping. Here it is, and that is a completely different concept. Now let's take example. Okay, for this word count example also you can relate that. So Spark is supporting three types of time windows for handling this kind of data. Tumbling means fixed, and then sliding and session. What is happening? Let's say for this tumbling one, let's say we are with the time, and the time is simply something 12. Okay, then this is your Windows 1, and then you are with 12 5 12 5, and this is window 2, and this is 12 10. Okay, and this is window 3, and accordingly you are going with that. So what is happening here? Your event is getting started with the this one. Let me do like this. So you can assume that this is window 1, like this. Okay, and then you can delete from the here, and accordingly you can have it. So if you are talking about this 12 to 12:05, your timing is 5 minutes. So this is one of the window. So this is one of the window open. Then 12:05 to 12:10. If you copy the same, then this is your window 2. This is your window 2, and accordingly you are having window 3. So this is window 2, and this is window 3. Now you can understand. So window 1 was open for 5 minutes. Here you are getting this right. And again for 12:10 you are having second window, and 12 for again 12:15 you are having third window, and accordingly this will be keep on keep on going with the next times and all. It will be a continuous process. So here if you see there is no time overlapping. Simply this is going to take tumbling is going to take. Okay, this will be if you are asking to do the count, this will be doing 12 to 12:05 whatever data is there. This will be doing aggregation on top of that 12:05 to 12:10 whatever data is there. This will be doing aggregation for that window time. So this is fixed. Simply you can say tumbling means fixed window. Now coming to sliding window. So in sliding window, there will be overlapping. I will be copying the same. Okay. So here if you see, let's say you were saying some 10 minutes or 5 minutes. Then this is 12 and 12:05. This is 12:05 and this is 12:10. So you are having one of the window here. Let me make it overlapping. So first overlapping is going from here to here. And second, again, it will be going from 5, 12, 5, 5, 12, 5 to 5, 12, 15, like this. And then let's say I am having some 20 as well, 12, 20. And let me copy this. And this is your window 4 for the 5 minute. And here, when we talk about this one, then let me copy this again here and we'll do enter. And this is for this one. So like this, here you can see overlapping either. This is the window 1, window 2, and window 3. And then we are going to what I have allowed here 10 minutes. Window sliding window is 10 minutes and slide time is 5 minutes. That means from this 12 to this is 12. Let it be. So this 12 to 12:05, this is one window. This is taking care. That is okay. But you are having a slide of 5 minutes only you were taking. So that's why this is having open window for the 5 minutes. And the in tumbling that was working with the fixed one. It was not taking care of anything. That's why it was very straightforward. But when you are coming for the slide window, so it is saying that okay, 5 minutes is okay, but slide window is 5 minutes and you can overlap with the 10 minutes. So what it is doing, it is starting from taking care for the data 12 to 12:10. That means for this 5 minutes also and this 5 minutes also. And then this is the window 1. Then you can say this is the window 1. What you are saying for the 10 minutes. Then again this is opening one window 2. That is starting from 5 12:05 to 12:15. This is your window 2 and accordingly here it is coming with window 3. Okay. Because it is taking care for this 10 minutes window as well along with the slide. So this is happening in the sliding window. Then you have next session 1. So session 1 is having something. Let me copy the same from the tumbling one. So this is only the major differences if you want to understand at the high level, because it is the very new concept for you, so it may have some complexity to understand. Then this session window is having gap duration. So for the gap duration, you are let's say we are starting our aggregation with the 12. So 12 to we are saying gap duration is 5 minutes. So 12 to 12:05 and then 12:05 to 12:10. So here this will not be there. Let me revert that. So what will happen? 12 to 12:05. Then let's say we are here with the 12:04. 12:04, and then it is opening a window 1, and then this is going towards window 1 5 12:05 to 12:10. This is your window 1 because you are looking here for the uh, 5 minutes, right? And this is, let's say you are this is 12:04, and here before 12:10, here we will, I'm just trying to give example 12:09. So again you are having some 5 minutes duration. Okay, like this 12:04 to 12:09, that means you are having 5 minutes. Just I try to give you one example. That means session is going to be, how session is going to be closed. So here 12:05 and then 12:10, so this will be getting considered as window 1. This will 12:05 to 12:01, this is going to be considered as window 1, 12:05 to 12:10. And then again here this is going to be started with, let's say this is 12:14, and I'm saying 12:15. This is 12:14. Just I'm taking 1 minute back, and then this is going to be with 12:20 something. This will be keep on going. So what is happening here? This is just going to check when session will be closed. So here session will be closed at this is 12:04, then this is going to be 12:09, and 12:09, then let's say there is some gapping for the data. So let me go through the diagram, that will be more easy. I had open it somewhere. Okay, so types, like here, let me come down. So this is again, this is about DataFrame. Okay, I guess it is not there. This is this one, and then here if you see, this is about this is giving the details about Windows operation. So this is also for this sliding itself. Okay, here you can see this is the original time 1, time 2, time 3, then time 4, then time 5, and then this is one of the window based, and then for the window 1, then for window 2 and window 3, accordingly this is going to take on the data. I wanted to show something else, but that is not here. Okay. So here we are. Yes, it will be here. So here you can see all the types of sliding. We have three types. Here, let's see at the three one. This one. We have three types of windows and it supports three. One is tumbling, that is the fixed one. Then we have sliding and then we have session. So for tumbling windows, 5 minutes. If you see at 12, we are receiving one of the data. For example, then this is 12:05, then this is 12:10, 12:15, and 12:20. For each of the 5 minutes, this is receiving the data from the source, and this is opening a window. Window 1, window 2, window 3, window 4, window 5. Each window is having 5 minutes data only, and that will be keep on processing. So let's say, for example, you are saying how many customers visited to this website for the 5 minutes. So this is not going to have any overlapping. Simply this will be doing the aggregation based upon that. Now coming to slide window. So for the slide window, this is having overlapping. You are talking about 10 minutes and then slide the 5 minutes. Then this is opening for the 10 minutes. If you see 12 to 12:10, this is one of the 10 minutes slide. Then 12:05 to 12:15. This is the another slide. 12:10 to 12:20. So always you are seeing 10 minutes sliding is there. Here it is having 5 minutes overlapping, right? Here you see a slide 5 minutes. So 12:05 to 12:10. This is having data which it means in this batch is completely fresh. From the next batch, this takes legacy data also for this 5 minutes, 12:05 to 12:10, and it is taking 5 minutes next data for this time frame. Again, in the next window, this is taking 5 minutes previous data and 5 minutes current data. So like that, it is having overlapping of 5 minutes with this slide 5 minutes. Now coming to session window. So for this session window, if you see, this is for gap duration. There is any gap, you can define the time. Okay, 5 minutes, 10 minutes, whatever you want to check. That for this time, if there is no activity and if that is reaching to the threshold, then either this should continue or not. So this is like 12 to 12:05. Then 12:05 and then you have 12:10, 12:15, 12:20. Means for each of the 5 minutes, this is keep on going. Then if you see here, 12:05 to for this range means this range is what? Let's say you are taking any other time and this you are taking any other time. Then this is 4 to 14. This is complete 10 minutes. And here session window will be closed at 12:09 plus 5 minutes. That means 12:14. This is going to be closed. Then again, this is starting here from here 12:15. Then this one, then session closed at 12:15 plus 5 minutes equal to 12:20. So at the 12:20 session is going to be closed. So like that, this takes care of in the session window. So tumbling windows are a series of the fixed size, non-overlapping and contiguous time interval. And input can be only bound to a single window only. This will not be taking care for any late coming data or any late coming data in the sense, of course, this is going to work with the window. So that is going to take care about the late coming, but that will be having the fixed window and except that window that is not going to take any data either which was the previously or that is coming to the next. Then sliding windows are similar to the tumbling windows. If we talk about the next one, from the point of fixed size, because this is also having fixed size. If you see here, this is also going with fixed size only 10 minutes, 10 minutes, 10 minutes. But only difference is this is having a overlapping of 5 minutes. So that's what it is saying. Sliding windows are similar to the tumbling windows from the point of being fixed size, but window can overlap. If the duration of slide is smaller than the duration of window, and in this case, an input can be bound to a multiple windows means there can be multiple windows as well. Here it is giving only single window, window 1, window 2, window 3, but there can be based upon the time and based upon the data. So tumbling and sliding windows use window function, which has been described in this example. And then you have finally session window that is having different characteristics compared to the previous tumbling and session window, sliding window. And session window has a dynamic size of the window length, which is depending upon the input. A session window starts with an input and then it follows in with the received input within the gap duration, and that session window get closed when there is no input received within the gap duration. After the received latest input, you are receiving the input and then there is nothing, no data is coming. Then in that duration, this is going to close the window. For example, you can do with this like session ID count equal to if you want to do the count. So window is open in the Spark streaming just to make sure that if you are doing any of the aggregation with some time range, then you can do with that. Here you are having three types, that is your sliding, tumbling, and session. Where you are having either overlapping or non-overlapping. Okay, and then this is good for doing this kind of trending analysis and all. That is the part of most of the project. But as I said, for the interview purpose, people are more interested to know about your streaming experience, what you have did, how you did, and this can be part of interview, but not very frequent. This is not very frequent, but better if you know. And if you go, this is Spark documentation. If you go through this, this is very lengthy. So that is not good to means it is good to go through this, but everything you can't capture, right? So just to go to the high level and focus on the necessary part only. So you can simply go to the overview of the windows and understand about the tumbling, sliding, and session. And if you are good to explain about this time overlapping and what kind of aggregation you can do, like taking the count, a group, doing a group by, then open the session window of the fixed time and overlapping time, then that explanation would be enough. Nothing more required. It was okay, or it was having an issue, any challenge? So if you go to this document, anyways, this will confuse a lot. So don't go with all that. Okay. You will be having issue just to go through this three concept only, whatever I said. But if you want, you can go through multiple, go through this, and multiple things are here about uh, joining here. Let's say you are doing the semantic guarantee for the aggregation and watermarking. Then a watermark delay, where 2 hours guarantees that the engine will never drop any data that is less than 2 hours delays. If you want to handle the so any data less than 2 hours behind in terms of event time, the latest data processed till then guaranteed is to be aggregated. And here this is the guarantee is strict only in the one direction. Data delayed for more than 2 hours is not guaranteed to be dropped. So how this is mostly taking late coming data for the event, for the timing period, for the open window. You are opening the window of 10 minutes, then this is going to take care for the 10 minutes data. That means at the same time this is processing your streaming as well, and along with the streaming, this is processing, this is taking care for that window time as well. Okay, then if you want to do some join operations, then semantic static joins, then you want to do some different things over the data, that all you can apply. Any question here? No. Okay, this is one of the point. Here you can see streaming deduplication. So you can deduplicate the record in the data stream using a unique identifier in the event. There can be some duplicates, right? So if you want to handle that, that also you can. This is exactly same as deduplication on static using the unique identifier column. And this query will store the necessary amount of data from previous record such that it can filter duplicate records. So with watermark also you can do, and without watermark also you can. So with watermark, if there is an upper bound on how a late data duplicate record may arrive, then we can define. And without watermark, since there is no bound on when a duplicate data may arrive to carry stores the data from the all past records. So either with the past records or with the current record, you can handle the duplicates. And handling duplicate is the crucial means I can say that this is really very crucial, and we should always take care about handling the duplicate data, not with the streaming part only anywhere in any of the project. Then policy for handling multiple watermarks. If you have single watermark, then fine. Maybe you can have some kind of join. This is you can say, right? You are having one input stream one, then input stream two, and you want to join both of the stream to get the final output. So in that case, you can have multiple watermark, and then you are going to resolve that. Then again, there are some unsupported operations as well, like limit and the take of the first 10 rows are not supported in the streaming data sets, and distinct operations on streaming data sets are not supported. Sorting operations are not supported. Few types of outer joins of on the streaming data is not supported. So multiple things are there which is not supported also, because normal transformations are different, and if you are applying the same over the streaming, then that would be different. Because if let's say you want to do some limit or first end record, here it is saying take the first end record. This is streaming. This is let's say right now it is 8:11. My count, my first record is ABC. Maybe in next few seconds, my first record will be XYZ. This is keep on changing, right? Because data is keep on coming from the source. So that can be different. That's why there is having some limitations, and these operations are going to be unsupported. Accordingly, this works. And then you have some configurations. If you want to look here, you can look into like state store, then again for block size, block cache size. Then if you want to have some max open files, and here you can see if you are talking about max open files, then the number of open files that can be used by the RocksDB instance. So forget about RocksDB. This is just mentioning one of the example, but configuration will be same. Configurations you can have in mind. And I do not want to confuse you more, so I will not go much into this, but I will. Okay, so this is about output. If you are going for the output, then here you can see write stream dot format Parquet. You are writing the data as a Parquet format. Then Kafka sync. You can have write stream dot format Kafka. Then you are writing the data to Kafka. Okay. Then for each sync, if you for each of the data whatever you are getting, then you want to start. Then console sync for debugging purpose. If you want to read in the console itself, uh, means write the data. After reading, write the data to the console just for debugging purpose. Then memory sync. If you want to have some this kind of requirement for the debugging, then you can go format memory and query name. So you can have the different functions to sync the data in the streaming one. Here it is defined defining that thing, file sync that can be appended, Kafka sync that can be append also, update also, and complete also. Append means it will be keep on updating the data. Update means if any updates are coming, and complete means whatever, keep everything. Okay. Then for each sync, this is also working with all three modes, append, update, and complete. For each also doing the same, console also doing the same, and memory sync, this is only for append and complete, but not the update. This is not going to update the changes. So likewise, in streaming, we are having multiple sources, multiple targets we can have. So here you can see they use existing batch data sources for many storage systems. There may not be a streaming sync available. Not possible that everywhere streaming is there, but if you want to work with that, then you can have some alternatives where there may already exist a data writer for batch query. So using for each batch, you can use the batch data writer to the output of each micro batch, small batch as you can. Then write to multiple locations. If you want to write the multiple location, that also you can do. Here you can see the example. Okay, batch df persist, then batch df write dot format, then batch df write dot format. You have multiple uh, writing up options, and then finally you are saying unpersist. You are unpersisting. I believe that you remember we had discussed about this unpersisting, that whenever you are caching the data, persisting the data, then we should not forget about unpersisting. Otherwise, unnecessarily this is going to keep the data in memory, and that will be a part of your shuffling, data moving, data communication, multiple things. That's why here also, if you see this is first persisting, then do whatever you want to. Then finally, this is unpersisting. So like that, we can work about. I believe that I can close it here. Anyone has any question about this? No? It was clear. What about you, Naresh? I will start from you only.
Yeah, all these things we need to go through because we, all these are new concepts now.
No worries.
So it will take time.
Okay. So in streaming part, what you can focus? First thing is your streaming. Okay. Then you are having a structured streaming, the streaming with the Spark. Then you can stream with Kafka. Then you can have sources, multiple targets. Targets means sync. Okay, source and sync. And then this window function. This window was just to handle the late coming data with some fixed window, because if your data is coming with the streaming, then that is coming for the particular time, and that is keep on processing. But if you want to do some aggregation with some time range, like I want to get the count for this sold product, whatever was sold in last 10 minutes, last 20 minutes, then how you can do. So for that, you have to go for this windows. Okay. And in these windows, you have three types. So these three types of windows, where in tumbling you have no overlapping. Whatever time is defined, it is going to process with that. Sliding, you are having overlapping with the time. And then session window, there this is going to run with the gap duration. If there is no activity, no threshold, there is the gap, then window session will get closed. Then you can work with the real-time streaming. You can work with the batch, micro batches. Real-time streaming means as soon data is coming from the source, let's keep on processing. Micro batches means you want to have some control that data is coming from the source, that is fine. But let's process in small batches. Like if data is coming all together, let's say 50,000 data comes all together, then you don't want to process all 50,000. You are just saying, okay, let's process in 50 seconds, 1 second, 1,000, 1 second, 1,000, like that. So you are going to make sure that everything is running smoothly. So that will be part of micro batches. Then yesterday we discussed about and this checkpointing. Checkpointing is a major thing in streaming. If you are talking about streaming and you are not talking about checkpointing, then that's not good. So you should be good with that. So majorly you can focus on streaming, real-time streaming, micro batches. Micro batches means near real time. So real time, near real time, and then checkpointing, that is to taking care for all the references, saving offsets, metadata details. What means that will be having the reference for the last processing, about the states of the processing. And then for the timing frame, this is the windows where you are having some three types, and you can go with that. So you can have a look. Okay, you can take the overview, and then you can try to go through this. I believe that it will be fine, and try to do the exercise as well. That will be helping. And this is weekend, right? So for the exercise, I will be means you will be having Kafka plus Spark streaming both. If possible, just try to go with that and try to do that. I hope that everyone is okay, or if you have any question. If you have any question, just let me know. No? Okay, then fine. Then I will be sharing one of the interview. Okay. So let me know if you are good to see my screen. So this is one of the interview. This is about this is the expectation 10 plus years of experience. Okay, this is a startup and individual contributor role, and the key focus for the interview is SQL query writing, communication skill, and Python coding. Here, if you come to this, this is the Python, and write a Python function that reverse the characters of each word in given string. So this was simple question, and it was a live coding. You have to write the code and you have to run this. Okay. Then input is data engineering, and this is the expected output. How you can do that. So I had did it. So I will just show you. This is the question, right? Write a Python function, and here you have to run this and you have to get the output. So just I wanted to show you that how simple this question is. There is nothing. Only you have to reverse the word. Reverse for the every word in the sentence. So what you can do, you can simply split. We need to split each of the word in the sentence, and then when we were discussing about the Python, then we had discussed how we can reverse. So within this double colon, you can reverse the data, and then joining that back to get the output. So simply this is just one line function where I am just doing the split and then reversing that and then joining that back. And this is my input data engineering. I will be just trying to use this reverse word function, and this is my input string data engineering, and let this comment, then run this. So you can see data and engineering, right? So this kind of questions can be there. And if you see, this is this interview is for more than 10 years of experience. So what they are looking for, that is nothing. This is just a string operations. And in that string, simply they want to understand if you have knowledge, you have to just reverse that, nothing else. Even you can have another alternative approach as well. Just I have tried to do with this, but you can try something else. Then there were two SQL questions, okay, and I would like to go through that, and I would like you to practice that as well. So for another Python function, this was something where you have data engineering, and you have to count how many vowels are there and how many consonants are there. Okay, so anyways, they had provided me the output. This one vowel 6 and consonant 9, but this was wrong. Actual should be vowel 7 and a consonant 8. It should be the output. Okay, so you can write your own code here. This is about finding the memory address. This one also we had discussed in our Python class, that this is the A, this is the B equal to A. That means this will be sharing the object of A, and C is also having same, but this is variable name is different, object is different. So either they will be addressing the same memory or not. So this is a single line code. Just you have to check the ID, memory ID. You can do that. And then this is the follow-up question. Okay. So how does Python garbage collector handle circular references, and what are the functions sys get size of and GC model used for in-memory profiling? Again, you can make sure that this question is related to a startup. A startup is always in a unique way, right? They are having, they will not be having lots of things. They will be simply focusing on something, and as they are in a startup everything is fine. Even pay wise startups are too much good, right? So they focus something deeply. So you do not think that this is going to be for all the interviews, no, but for small companies, small scale companies, startups and all, you may face this kind of, and I believe that these are very simple things if you are practicing hands on. Then this question was related to API. If you have any API related experience, then simple question, write a Python function to fetch all the user data from the API until there are no pages. Okay. So let's say you are reading the conference page for the organization you are working, and there are multiple spaces, then multiple pages, and your requirement is to read all the page until that is there is zero, the count left is zero. Then a follow-up question is how would you handle rate limiting or API failures, and how would you parallelize API for the efficiency? You can do just Google and you can try to get it. Then two questions were from the SQL. I would like you to practice these questions. These are very real time and genuine questions. And if you are practicing that, then you will means similar questions you are going to get in multiple interviews. Here they had provided all the things like you have a sales table with the following columns: sales ID, product ID, sales amount, sale date, and region. The task is write a query to find the top three regions that contributed the highest total sales in the last 90 days. Okay, and include regions with no sales in this period. So this is the table. Even they had provided me the table structure as well, and they provided me the data as well, that this is inserting the data, and then table structure. Okay, so this is different one. So like this, and then I had one more SQL question. So this SQL question is you have a product table with the column, a product ID, product name, price, and category, and you have one more table with column sales ID, product ID, quantity sold, and sale date. That means you have two tables and you have to join. The query is write a query to find the most sold product each category for the past year. So in above SQL, they are looking for the product for last 90 days, and here they want to do the aggregation to do the last 1 year and include categories where no sales occurred. Okay, no sales occurred in the sense, even here they have given the example that this is something 200 days, then 200 days ago, still within a year, and additional sales for the three means interval 2, interval 300 and all. So all the things are there. You have to just go through this. And even I will share this exercise. Okay, you can try out for that Python one also, and for this SQL as well. And I would like to go through this SQL mostly. You should go with this. Okay, and let me. I think that should be open. Okay, yeah, this was the question. This is the table structure. Okay, and in this table structure, this is thing and this is the thing, and then you have to write the query. So this was the query I had written, but you can try similarly with some different one. Okay, and then this is the another query. So if you think that if you have some good practices, this is no much I don't think that it's very complex. Here, for this example, uh, 200 days still within a year. Did I capture this? Okay. So here for this example, simply they wanted to find out. Okay. So here if you see, I have used this row number. Do you remember this row number? Anyone? When we discussed about this?
Yes. Economic.
No?
Yes.
Okay. So this is for the window functions. Okay, and in the window functions I had shared with the row number, dense rank and all. So just simply I'm trying to create the rank so we can find out about the rank in whatever we are looking for, 0, 1, 2, 3, whatever. So I will share this and just to go through this. Anyone has any question here? Not for this interview question, for any another thing. Then I will move to the next. If anyone has anything, then please let me know. No question. Okay. I just let me open that. Project nested flattener. Okay. So I wanted to share this project with you people. I believe that. Okay, but the thing is, you have to do this project seriously. Okay, you are good to see my screen, right?
Yes, Anamika.
You people can speak.
Yes, we can see.
I believe that you are good to hear me and you are good to see my screen as well.
Yeah, Anamika.
Om Prakash, you are on mute.
Yeah, we are able to see.
Okay, so this is one of the project for the JSON data. JSON data where you want to extract the data with its transform with some complex transformation. Okay, so where you have to process the JSON data by transforming nested structure into a flat format and extracting relevant metadata and standardize the data formats for the further analysis. Just let me verify something else. Okay, yeah, this is fine. So here you have two things to do. Means the same data you have to get into the two types of output format. What is the objective of this? This JSON will be very nested in the real time. We are going to get the same. In the real time, most of the time you will be having nested JSON and you have to deal with that, right? So this is transforming nested JSON, convert complex nested JSON structure into a simpler flat format to facilitate easier data processing. Then extract metadata. So retrieve and clean file metadata, including names and dates from JSON and file paths. Then standardize the dates, convert various date formats to a consistent UTC format. UTC format is always good because we are working as a global team member and we are having multiple different timestamps in the data. If let's say you are working with 4 different countries data, then there can be some different timestamp, time zones and all. So why not to get it as a universal one, UTC, right? Then what you need to do? You need to flatten JSON data, then extract and clean the metadata and convert the dates doing the ETL to apply the transformation and then data integration. That data integration you can do either if you have set up the Kafka already, then you can work with the data and then you can push the data to Kafka topic. Or if you have the SQL, then simply you can first push the data to the SQL, then build a data pipeline, read from the SQL, do the transformation, run your Spark application, and then push the data back to Kafka topic, build a proper data pipeline. Okay. Then what is the expectation for this? You have input and you have output. Input should be nested JSON strings with the complex structure and file path for the extracting file names and the dates and then date strings in the various format. Output will be flattened nested JSON with the simplified structure then cleaned file names and extracted dates, and then dates converted to a consistent UTC format. Then next come to this data. Summary of the input. Here, for the, as I said, you have to, this is mostly for flattening the nested JSON. So flattening nested JSON, where you have to, output should be flattened nest JSON with hierarchical key. You have to get the hierarchical key. Then extracting file name from the file path. Then clean the file name and extract the date from the file name. And then standardize the date format and the cleaning attributes and values. If data is having some issue, then do the cleanup. Then from here, we are going to start how many columns you are going to get in the output. First column will be parent ID, then item ID, then file name, and then collection date UTC and the target object class, class instance, relation tree, attribute value and attribute name. As of now, this looks very complex. Okay, so before explaining all these things, I will be going directly to the data that will make your job easy. So this is the data. Let me open that first with Notepad. Or let me copy this itself. So this is the data. Okay. If you see, this is the root test log. Then you have test and test is starting here and ending here. You can see data type, then test info, then test version. This is one description. In description, you can see here it is wrong. 2 stars are there, one minus hyphen. Hyphen is there, that is wrong. It should not be. So it should be cleaned up. Okay, if this any kind of uh, special characters are there in the word or sentences in the value section, you can take care of that. And then here you can see hardware info. This is one of the another attribute. You have hardware info, then revision, then file creation date time. Here if you see data date and file creation date time. So what is happening? Let's say whenever file is getting created, that time uh, that time is different. And well, maybe when this what is the data for the date for the data, that can be different. Okay. So in the code, what you have to do, you have to check if this data rate is available, then take this data. If this data rate is not available, then take this data. So just I will explain that later. Here if you see the time zone is different. Here it is plus 530, here it is plus 630. So now you can convert that to UTC. Then monitor. This is the monitor data, monitor type, then hardware info, model name, index. Then you have disk. Disk is a list of the JSON. Here if you see, this is the disk, and disk is having, let me max, in the maximize, you can see here. This is the disk one. This is disk one from here to here. And then inside the disk you have partition. So for partition, this is the partition. You have partition 1, partition 2 and partition 3. So this kind of data you have. Okay, you have nested data with array, list and all. And then accordingly you have processor. Here is the processor. Processor also list of the processor. This is processor 1, this is processor 2, this is processor 3, and this is processor 4. So accordingly you have to flatten this JSON. How you can do that? Let me go to the output, then I will explain each and everything. This is the input, and you, whenever you are working with this, you are saving the file, then save in this format. Okay. So whenever you are saving in this format, you can extract the timestamp from here as well. This one. Now going to next. This is the output. So let me expand the output. If you see here, what I have tried to get. I have created one of the parent ID. Parent ID, if you see, this is very common for each of the row. Why common? Because I have taken parent ID means unique ID for each of the file. For a single file, these many rows are there. Okay. For each of the key and value, you can see there is a one row. Data type, test info, test version. If you see from here, you have data type, test info, test version. So for each, we have one of the row. This belong to one file. We can have multiple files, right? So how you will understand that this data belongs to which file? Because of that, we can have a parent ID, and for each of the file, we can have unique parent ID. So that will be helping to identify that this data belongs to which file. So this parent ID will be unique file as per file level. Then you have item ID. Item ID, you can see this is the unique number. You will not see the duplicate. So item ID is unique for each of the parent ID. Like for the parent ID, okay, how many item IDs are there? There can be item ID can be duplicate for the different parent ID, but inside one parent ID, this will be there will not be a duplicate. This is the dynamically generated number, just for the reference of the project to making sure that it's consistent, and you are making it you are making sure that how you will be working with the data, how you will make sure that this data belongs to this. If you want to have some reference, how you will be getting it. Then file name. This file name I have extracted from this file name itself. This is the file name, so you can have some file name. I have just extracted this name. Okay. And output. So this is the file name. Then collection date UTC. So collection date UTC, we are going to generate it. How you are going to do that? Here is the logic for this. So here I will copy this as well. This is the file name. Here if you see collection date, first you have to check extract the data date from the file. If data date is available, then take that. If you go to the file, you have data date. If that is available, then take this date. Then if that is not available, then if that is missing, then take this one, file creation date time. This one. This is available in the in this JSON. You can see file creation date time. This one. And finally, if this is also not available, let's say this both are missing from the JSON, then you have the file name here, right? Here you have the file name, and in file name you have the timestamp. So take timestamp from this one. So first you check both of the attributes in the JSON. If that is available, first one is available, then take first one. If not available, then take second one. If that is also not available, then extract the timestamp from the file name and then convert to the UTC in the expected format of YYMMDD with hyphen. Okay, and then get this column data. Then target object class. Target object class in the sense from where this is going to be. So this is the relation tree. Relation tree I can explain you for the data type what is the relation tree. So see this. I will just minimize it. And you can see here for the data type. This is the data type. So for this data type, relation tree is test log and then test. And inside test, this data type is right. So this is the parent, then this is the child, and these are the child of this. So this is the relation tree. Now coming to this this one, row number 7. So for this row number 7, here you can see hardware info ID. So this is hardware info ID here. Who is the parent for this? Parent for this is test log, and then test log, inside test log you have hardware info. This test and hardware info is siblings. Okay, but parent is this one. This is the parent of this also, and this is the parent of this also. So here you are maintaining the relation tree. Test log, then hardware info, and then this is the attribute name. Okay, and then this is the attribute value. Accordingly, coming to monitor, if you go to the line number 11, this is row number 11. So for monitor, what is the relation tree? Monitor is the child of this hardware info. Okay. Test is getting ended here, but hardware info is getting ended at the last. So monitor is the part of that. That means monitor is having parent, that is hardware info, and hardware is also having a parent. So for monitor, if you see a test log, then a hardware info and then monitor. So this is the parent, and inside monitor you have 4. Monitor type, then hardware info, then model number, model name, and then index. For each you can see here the row, monitor type, hardware info ID, model name, and index. Then coming to disk. For disk, if you see here, it is giving the same parent this relation tree, test log, then hardware info, then inside hardware info you have disk, and then you have partition. But you are getting disk 1 and partition 1. Why this is? Because we are giving the indexing. Indexing to understand that this data belongs to which disk. Here, if you see the data, you have 2 disks. This is 1 disk. I will minimize it. And then you have another disk. This is okay. Here your disk is getting ended. Means disk is a list and disk is having 2 disks. This is 1 and this is 2. So for both the disk, you are having here the data you can see. Inside the disk also, you have partition. So inside the disk number 2, this is the disk number 2, you have a single partition here. So if I go here, then I can show you. For disk number 2, you have partition, one partition only. So we are not giving any number, any indexing number, because if single number, then indexing is not required. But for disk number 1, there are 4 disks. So 3 disks. So the indexing is required 1, 2, 3. So that we will be having the understanding that this data belong to which disk. So let me expand this one. So this is partition. Partition 1, hardware info ID, then disk ID, then index, then size MB, then name. Okay. Then again disk 2. Sorry, partition 2. So partition 2 also having the attribute name is same, value can be different. So accordingly, I'm giving the number. And here for this column, if you see, data is getting derived from the relation tree only. Okay, that okay, this is the data hardware info ID. This hardware info ID belongs to partition 1 that you can extract from this relation tree. And this partition 1 is the main root for this partition one is partition, because partition is having partition 1, 2, 3, 4 and all. Okay, so like this you have to extract. You have to extract all the key value, then its relation tree, parent to child, have the indexing if that is list or array kind of, and then get accordingly its instance class and object class. Object class is the main class. Instance is if it is having any instance. Okay, for that one. So here if accordingly disk 2. This is the disk 1 data where you can see idle time, then hardware info ID. If you go here, disk 1. This is disk 1. Okay, in disk 1 you can see idle time, hardware info ID and all. So accordingly you have to convert this complex data with its relation tree into this tabular format. This is one of the requirement where you have to create this parent ID. Parent ID means that will be unique ID for the file. Here I am giving you one sample file. You can have 10 file, 100 file, 1000 file. So for each of the file, if you are generating that many records, finally how you will be understanding that this data belong to which file. Then you can have unique ID for each of the file. Then this is the item ID. Item ID I created unique for the file level. Means a row level for the file. So this parent ID is unique for the file level, and this item ID is unique for the row level for the file. Then this is the file name I extracted from the file name input. This is the UTC timestamp. UTC timestamp. I believe that you understood how we need to do it. We simply need to check the field if that is available. Like here we have, let me just repeat it. So you have three options. It will be above. So for I have given all the mapping what you have to do for each of the column. Like this is if you start from here, parent ID, then mapping logic generate a unique ID at the file level using a fixed 9-digit. You can have any digit. Here I am giving 9-digit. Item ID generate a unique ID at the row level using a 9-digit random number. Then file name directly map to the input file name, whatever file name you have given. Then collection date UTC. For that you have three things. One, primary source you will be checking in the loop, means in your function if this data date is available. If it is available, then don't check for the next, just return this date with the UTC format. Then secondary source, if this data is, if this field is missing from the JSON, then look out for this one and do the same with this timestamp. If this is also missing, then finally take the timestamp from the file name. In file name, we have timestamp included with the file name, extract and then convert into the expected format. So like that, you have to do that. Then for the target object class and target object class instance, as we shown in the output, relation tree, I believe that you have understanding. The relation tree means all the parents and sub means parents about parents and who is the parent of that, like that, all the complete relation hierarchy level. It has to capture all the things. Then attribute name and attribute value. This is the final what is the attribute name and what is the attribute value, so that you can extract. And here this is just for the example, but actual example I have already mentioned in the Excel sheet that is attached in this document. Okay, and you have to extract the exact output with these columns: parent ID, item ID, file name, collection date, UTC, and all these things. Then next you have to work with the same data, but output model will be different, because let's say this is structured, that your output is going to be converted into the structure format, a tabular format. And if you want to store in any of the table, let's say either your SQL table or Hive and all, then you can do that. But if you are working with no SQL database, then what you will do? So for that, this is the use case. Okay, so split each nested JSON and store it separately in any NoSQL data with its metadata details. Okay, for each child node, it will be having a splitted separate JSON, and all attributes should be filtered out if its value is null or blank. If any attribute is there, if its value is null or blank, then just filter it out. That is just a use case. Then this is how you have to get the output. Here you can see logic is same. Whatever logic you have implemented, that would be same. Only the thing is storage format is different. There you were storing as a tabular format because you are going to work with the structured data set with any of the relational database. And here you are going to work with the NoSQL database. Let's say your target is Kafka topic or MongoDB, or if you are working with cloud, then maybe in Azure you are working with Cosmos DB. In AWS you are working with Dynamo and all. So if you are having different sources, then your output model will be also different. So let's assume that you are working with that kind of targets where you cannot push the data into the structure format. Then this is what you are going to do. So you are converting the each of the record as a JSON. Okay, and not each of the record. This is for the domain wise. So here item ID, then processor. For processor, you are capturing the entire data. That means average frequency, then max frequency, then minimum frequency. So in if you go here for the processor, if you see, this is having index and minimum frequency, maximum, average. You are having four. So all four are captured as a single JSON. Again, so this belongs to processor number 1. Then again for processor 2, this all will be captured into a single one. That means for 4 processor you will be having 4 JSON document. Okay, if you come here you can see this. So this is the one. Then relation tree also captured here. This is the collection date UTC, whatever you converted the date format. Then file path, input file path, whatever you have, you can have. Then object class instance, then object class parent ID, item ID, everything we are going to maintain here. And then if you split that as that output, then these many JSONs you are going to get as output for each of the module, for each of the domain. You will be having one. Like if you look out for the processor, then for processor, let me just search. Let me find it. Okay, so this is where again one time, again one time. So total 4 times it should be. Okay, so like that, like for disk we had 2 times. So let me search that disk. Do we not have disk? Okay, we have disk here. So this is the disk, and for this disk, this is capturing for first disk. Then you will be having the second one, and accordingly it will be processing all the things. This is for disk 2. If you see here, object class instance, this is disk 2, and this is the relation 2. So likewise, you have to take this input data and create that means do properly. Pure Python code with PySpark. Okay, make the source and sink both. Source you can take either as a file directly or take from the database. Sink you can try to for the structured data you can push the data into the SQL table, and for unstructured this same structure whatever you are converting into this JSON format, that you can try to push into MongoDB or Kafka topic as your output format. Okay, and try to do this with proper coding, proper function, and not in a kind of rough that okay you are just doing the rough thing. No, do this properly. You can take 1 week, And then you can give me any date, either in next Thursday or Friday, and we can have review whoever has did and what you are going to do, how you have did it. And if you will be doing this, then that is going to be helpful more. And this is a real time project. Okay. This is a real time project, and you will be learning a lot whenever you are working with this, because you will be getting the things how you are going to handle the nested and complex kind of data, and how you are going to define all the things. So in this document, I have tried to explain all the things. Just to go through this and see if you have any challenges or any issues. So today I will be sharing the exercise for that Spark streaming, and along with that I will upload this as well. Just to go through this and let me know if you have any challenges or anything. Then Monday we will be starting with the MongoDB. Okay, that will be 1 day session, and then we will start with the cloud. In between, if you have any question from the previous thing, then just let me know. All good?
Yes, Anamika.
Okay, then I believe that it's okay. Fine, then let's meet on Monday. Have a good day, weekend. Bye.
Bye. Bye.